Hey everyone. Let's take a look at topic number 13, something called transformation of function. So we talk a lot about functions so far. Okay, we start out with the basic graph of different types of function: linear, quadratic, absolute value, square root functions. Okay, and even we even I even draw out the rational function as well. All right, then we talk about increasing, decreasing part of function. We talk about domain and range of the function. We take a look at whether a graph is a function or not. Okay, so now we're gonna dive a little bit even more deeper. Okay, of those of the equation part of the function. Okay, so once you kind of know what the function looks like, it turns out these functions. Okay, these functions can transform. What that means is it moves on the graph. So transformational function means the graph of the function will shift. Okay, they go to the right, they go to the left, they go to different places on the graph. They will do reflection and they will even stretch or compress. Okay, so I'm gonna show you how to, kind of show you how those functions will behave. So this is almost like a behavior of the functions, and the behaviors of the functions can be identified from, from the equation part. If I write out a function for you, you actually know how that graph will behave before you even graph it. So the first thing is called the vertical shift. Okay, first thing is called a vertical shift. If you have a function, okay, f of x, I don't care what it is, it can be linear, quadratic, or whatever. So I'm gonna let me see. I don't, I'm gonna use a quadratic. Okay, so if I have a quadratic function, f of x, let's just call it x squared. How about that? I'm gonna write x squared. All right, f of x part is where the x squared is. Okay, if you plus a number like a one, that means this parabola, this u, will actually shift up 1 unit. Will shift up from where? Well, from the origin. So if you only graph x squared, if you only graph x squared, we know it's a u, but the very bottom of the u is actually sitting on the origin. Okay. So if I will go down here to y2 and then draw another x squared but plus 1, then you can see the second graph actually shift up 1 places. All right. So if a function plus a k or plus 1, that means it is moving up 1 unit. If it's a minus something, if your function is minus a number k, then you actually shift down k number of units. Okay. So let me kind of draw it. I'm going to kind of draw -1. All right. I'm going to make this line darker, the second line darker. The one that shift down is a little bit darker so you can see it. That's the original one. And this is a darker one. It shift down 1 unit from the origin. Horizontal shift. The function can also shift to the right and shift to the left. So this is where it gets a little bit weird by looking at the notation. If the function, if this h, if it's inside the function, then the function can shift to the right. So the formula is calling for minus sign here. All right. If the formula is calling for a minus sign here, that means the h is actually positive. Okay, so within the function, if you're minus a number, it's actually shifting to the right. If it's plus a number, it's actually shifting to the left. So what do I mean by that? Well, a good example here will be a square root function. So if I will draw you a square root function, square root of x, right? If I simply draw square root of x, we know the starting position is at the origin. It's going this direction. But within this function, within this square root, if I say -1, okay, that means this starting point will shift to the right 1 place. So I'm going to draw a regular square root of x. Okay, and I'm going to purposely close this parenthesis. This is what a regular square root of x looks like. Now, I'm going to go to the second one, and I'm simply going to type in square root of x, okay, minus 1. So this minus 1 is actually still underneath the square root. I'm going to go to the very right and make it darker. So this minus 1 actually will tell me it will shift to the right 1 places. Okay, it got to be within it. Now, so the k is actually on the outside. So if I have a square root of x, right? But the minus 1 is on the outside of the radical, then that become a vertical shift. You actually go down 1. So if it's within the function, that's what this notation here means. If it's within the function, x minus a number is shifting to the right. If it's x plus a number, it's shifting to the left. So I'm gonna do an x plus 2. The formula is calling for minus sign. So if this is a plus 2, let me write it down here. If a formula is calling for a minus, and when your answer is really a plus, that is really saying x minus a negative 2. That's why I shifted to the left 2 places. All right, so here on the second one, I'm going to say plus 2. And you will see this is the original one, and then it shifted to the left. Okay, so horizontal shift is within the function. Okay, within the function. So how would you recognize a quadratic shifting to the right and the left? Well, maybe whole thing is being squared, and maybe like a x plus 2. Now, this is still a parabola. Okay, this is still a parabola. So now within the function, since the x is plus a number, within that function, this will tell you the u has shifted to the left 2 places. So I can again draw a regular x squared, and this time I'm going to say parenthesis x plus 2, and then whole thing squared. So this is the original function, and then a darker one is shifted to the left 2 places. All right. So that's horizontal and vertical shift. Reflection about the x-axis, okay, or the y-axis. Y is equal to negative f of x. So that means if in front of the entire function, if there's a negative, that means the graph reflects about the x-axis, okay, or vertical reflection. So that means it's a mirror image reflects about the x-axis. Oh, I might have this one backwards. Hang on a second. Let me try it out. A good example will be, oh yeah, never mind. I was right. We talk about x-axis, mirror image across the x-axis. So mirror image about the x-axis. So what that means is, okay, if you have a dot right there, reflection about the x-axis, that means what? That means a mirror image on the other side of the x-axis. All right. Reflect about the y-axis, that means if there's a point here, then reflect about the y-axis, and that means there's a point right here. Okay, so you can kind of, if it's like a piece of paper, you can actually fold it along the y-axis, then this red dot will become that red dot. You're actually matching up. So let me show you a perfect example. Okay, so here's x squared. Okay, here's a regular x squared. In front of this function, if that's a negative, then it's a reflection about the x-axis. So here's a regular x squared. I'm going to do a negative x squared. And I'll make the second one darker. So you can see a regular U opens up, and the darker one with the negative sign in front of it is reflection about the x-axis. So that means that's how we know that parabola opens down. All right. Now, if it's within, if there's a negative sign in front of x, and that x is within the function, just like right here earlier, the square root function. If I draw a regular x square root of x, right, we know it's going that way. But if right in front of it there's a negative sign, if the negative sign is in front of the x within the function, then it will be reflection about the y-axis. All right, let me show you what it look like. Okay, so here's a square root of x, right, regular one, and here's a square root of negative x. And I'm gonna let this one to be darker. So the first one drawing is regular x, right? And then if there's a negative sign in front of it, okay, it's reflection about the y-axis. So that means if you take this picture and fold along the y-axis, then you will look exactly like that way. Okay, so that's what I mean about reflection about the x-axis and the y-axis. Okay, so these are the behavior of a function. That's the reason why, if you know this ahead of time, this is not going to surprise you. Square root of negative x is the picture of the square root of negative x is not going to surprise you because you know normally it's going that way. So why all of a sudden it's going the other direction? Okay, because that's a reflection about the y-axis. All right. Now, regarding to stretch or compress vertically, okay, this is a little bit tricky. Is stretching the graph out. If there's a number in front of the function, and that number we will stretch vertically if that number is bigger than 1. Okay, so I'm gonna try like this. Okay, the most dramatic stretch. I'm gonna draw you a regular quadratic function, a u, and then I'm gonna do a 3 times x squared. All right, so if the a is bigger than 1, then this will be stretched vertically. So I'm gonna make the second line darker. All right, here's a regular U. And then imagine you stretch vertically, pull it. If you actually pull this original U, pull it vertically, you will get skinnier. Okay, so that's what that's what it looks like on the graph, stretch vertically. If that same number A right in front of the function, entire function, if that number is between 0 and 1, all right, number between 0 and 1 are 0 point something. And any decimal that says 0 point something is like a fraction, a proper fraction. So if it's a proper fraction, then we will actually compress vertically. Compress vertically means take this original u and squeeze it. If you squeeze it, then this u is going to get wider. So I'm going to do a half. I'm going to say 1 over 2 in a parenthesis times x to the second power. All right, so the darker line is a compressed one. If you compress it vertically, then that u gets wider. All right. So what does wider mean? What does this wider mean? The wider means as the x value. Let me go to the table. Wider means as the x keep on going to the right or keep on going to the left. Okay. Wider means the y value is not increasing as much. So the y1 was the original u, 1, 1, 2, 4, right? But if it's a wider u, then the y value don't get as big, don't get as large as quick. So that's 1 comma 0.5, 2 comma 2, 3 comma 4.5. So getting wider means the y value don't rise as quick as the original one. Stretch. Okay, stretch vertically means the y value is actually what goes up very fast as x keep on going to the right and left. So very fast or wider, all that is comparing to the original x squared. All right. Stretch or compress horizontally. That would be referring to the numbers inside the function right in front of the x. Okay. So y is equal to f of bx. Graph is compressed horizontally by 1 over b. This is where it gets weird. By 1 over b if b is actually bigger than 1. Okay, so this part gets a little bit strange. Okay, so let me just give you a quick example. Okay, let me just give you a quick example. I'm going to use the square root again, but this time I'm going to compare a 1 over 2. Okay, so my b is bigger than 1, right? X. All right, so technically this is going to be compressed horizontally. But if 1 over b, if this b is like anything between 0 and 1, so 1 divided by anything between 0 and 1, maybe like a half. 1 divided by a half is technically a positive 2. 1 divided by a half means 1 times the reciprocal. So 2x. All right, so I'm gonna graph. So this is compressed, this is stretched compared to the regular. So this one I'm gonna do square root of half, close parenthesis, then x. All right, so when I enter the square root, it automatically give me an open parenthesis. So I purposely open and close another parenthesis for that half, and I put my x on the back and close it. Okay, so I'm typing that in. And the first one, I'm gonna do square root of just x. Oops, wrong button. So this is a regular one, right? Compressed. Okay, compressed horizontally. That's what it looked like. Kind of weird looking. Stretched horizontally. So I'm gonna do a 2x. This is a regular one, stretched. Okay, stretch horizontally. So I don't talk much about horizontal stretch or compress. I do more of a vertical. Okay, but on the homework, I might still asking you about horizontal. Okay, so we'll take a look in a minute. All right, so these numbers around, so you can say these numbers, within the function or outside the function does provides the function, the graph of the function of different behavior. All right. So real quick, for example, okay, we're gonna go through all this. For example, determine the basic, the type of function, okay, type of basic function, common function. What would you consider this one as? Linear, quadratic, rational, absolute value, or cubic, or radical function? Which one do you think is this function? When you look at the equation part of the function, you need to know what type of function that is. So you can kind of remember, okay, what that thing should look like. What type of function is this one? I'm just gonna circle it. This gotta be a rational function. This gotta be a rational function. Okay. So if you look back on, when we draw the rational function, there were two kinds. There were one that is 1 over x, and there was another one is 1 over x squared. Odd or even power. Okay, so this one would be considered as odd because this x is to the first power. So right now, I'm gonna purposely rewrite this. Okay, rewrite this problem. Okay, the negative 5 over x plus 3 plus 5. So I know there's two terms. So my f of x, my function part, is technically can be rewritten as f of x is negative 5 times 1 over x plus 3 plus 5. So the rational function portion is right here. Okay. This plus 3 right in the denominator right next to the x is this plus 3 is the same as saying within your function the x plus a h. The plus 5 out here is your k portion. That's your k. All right. The negative right here is in front of your function. So that negative is reflect about the x-axis. The number 5 right in front of the function 1 over x. The 5 is right here, stretched vertically, right? 5 is bigger than 1. All right. So determine the graph of the function shifted to the right, left, or none. If there is a horizontal shift, determine the number of shifts. So did I shift to the right or left? That would be this part right here. Within the function, okay, if it's x plus h, then it's shifting to the left. Because remember, within the function is always calling for a minus sign. So if it's a plus, that means it's shifted to the left. So we actually shift left. All right, how many units do we shift left? We shift left 3 units. Determine the function shift up, down, or none. If there's a vertical shift, we need to determine the number of shift vertically. So that will be right here. Okay, your function f of x plus k. All right, plus k. So that's positive, means we shift up 5 units. Shift up 5 units. Determine the graph of the function reflect about x or y axis. So reflect about x or y axis, that will be the negative sign, right? So my negative sign is in front of the entire function. So my negative sign is right in front of the entire function. So that will be reflection about the x-axis. All right. So none will be that sign, none will be is positive, just a regular positive. Determine the graph of the function stretched vertically, compressed vertically, or none. So stretch vertically. All right, stretch vertically, compress vertically. So vertically, stretch and compress is if you have a number in front of the function that is bigger than 1 or between 0 and 1. So I do have a number 5 in front of my rational function, so I actually stretched vertically. So that will be this number right here. I'm gonna use purple. Use green right here. That not 5 tells me a stretch vertically. Determine the graph of the function stretch or compress horizontally. Horizontally is if there's a number in front of the x within the function, right? If the number is bigger than 1 or between 0 and 1. Well, if you look at the x within the function, right here, this is 1x. So in front of it is a 1. So this number in front of x is not bigger than 1 or between 0 and 1. So if it is not, then you don't have any horizontal stretch or compress. All right. So the next thing, determine the x-intercept, if any. And we're going to plot it in number 9. So in a way, we're going to graph this function by hand. All right. Determine the x-intercept. So I'm going to show you. All right. F of x. Let me see if I can copy it down. Or I can just write it. Negative All right, negative 5 over x plus 3 plus 5. Okay, here's my function. So to find x-intercept means find x. To find x-intercept means find x when y is equal to 0. So I mentioned that in the previous topic before. So f of x is your y. So we need to set y equal to 0. So my equation should say 0 equal to negative 5 over x plus 3 plus 5. Solve for x. All right, so the right side, I got two terms. I'm solving for x, so negative 5 over x plus 3 is my variable term. My variable term is negative, so I'm going to move it to the other side because that will instantly become positive. So this should give me 5 over x plus 3 equal to 5. All right, so how do I go about solving this equation? Well, at the moment, there are two techniques. I can either multiply both terms by the LCD, which is x plus 3, or I can simply use a cross product. All right, so if I use a cross product, then the 5 will need to multiply both of these terms. So that will be 5 times parenthesis x plus 3. Set it equal to 5 times 1, which is 5. If I will multiply both terms by the LCD, which is x plus 3, then I will still end up on the left side, the x plus 3 and x plus 3 cancels out. So I still end up with a 5. The other side, I will end up with a 5 times x plus 3. So either way, I should come up, I should end up in this position. So I will distribute and then move my 15 over. So that should be 5x equal to positive 15, move over, become negative 15. 5 minus 15 is negative 10. Divide both sides by 2. X is equal to negative 2. So my x-intercept is going to be negative 2 comma 0, right? X-intercept, find x when y equals to 0. Negative 2, 0. Here's an x-intercept. All right, determine the y-intercept. Plot the y-intercept. So y-intercept means find y when x equal to 0. Okay, so I'm going to substitute 0 into my function. So that'll be negative 5 over 0 plus 3 plus 5. So that will be negative, simply negative 5 over 3 plus 5. So we mentioned this before. Whenever you combine a fraction with a whole number, okay, you can always use that little trick, how we convert improper fraction into mixed number, how we convert mixed number into improper fraction. So 5 times 3 is 15. Negative 5 plus 15 will be positive 10 over 3. So positive 10 over 3 is about 3.3. 10 over 3 is about 3.3 repeating. So my y-intercept is about 0 comma 3.3 repeating. So I'm going to just go a little bit above 3. 1, 2, 3. All right, so I'm still what? Yeah, that's fine. So I'm still writing my answer as a fraction. I don't write my intercept as a decimals, but when I plot them, I will need to know what decimal answer that is. All right, so just having these 2 points, of course, is not enough. So we will still need to grab this function in a calculator to help us to see exactly what's going on. Okay. Right now, I'm not teaching you all the way how to graph a rational function. I just want to show you how to find the intercepts first. And then we can put this in the graphing calculator and we can graph it to help us, to kind of help us connect the points. So got two terms, right? I got two terms. So I'm going to start off with a parenthesis for my first term, negative 5 divided by, the denominator has two terms for the x plus 3. So I opened another parenthesis for the x plus 3, close the parenthesis on the x plus 3, and close the parenthesis for the first term, then plus 5. So based on the picture here, This 2 intercept is actually the bottom portion of it. Something like that. And the other part will be something like that. I'm just sketching it. Okay. Turns out, if you look right here very closely, if you look at the function very closely, what is my restriction on the domain? What's my restriction on the domain? That x actually cannot be what? -3. So when I draw this picture, I sure don't want to cross over -3. So for the other part, I'm just gonna kind of draw it right here. Don't want to touch -3, -4. You know what I'm saying? Just kind of graph it like that. There you go, something like that. So that's how I'm gonna sketch it for right now. All right. So final restriction on the domain, I just did, which x cannot be -3. So all you have to do is set the denominator not equal to 0 and solve for x. So x cannot be -3. So what's my domain of the function? Well, this side keep on going left, this side keep on going right. My restriction is x cannot be what? At -3. So my domain must be from -infinity to -3 using parentheses, right? Because I cannot be -3. Or my domain can be from the other side of -3 and keep on going to the right. There you go. That's how you find all the answers. So I do kind of need the graphing calculator to help me, it's going to help me to graph other portion of it. In a different topic, I will show you exactly how to graph rational function, by hand. Right now, I'm just kind of showing you a couple things. All right, consider the following function. So this one is a absolute value function. We know absolute value function is normally a v. So I'm gonna just circle right here. I think on the homework you have to type it out. This as absolute value function. All right, so let's see. Remember, normally a rational absolute value function is simply absolute value of x. Okay, so let's see what we have added. Within that function, within the absolute value function, there is a +2. Okay, so within the function, okay, behind the x, if it's a plus or minus, that's horizontal shift. So that +2 right there tells me that it has shifted left 2 units. Okay, the entire function plus or minus a number, plus or minus k, tell you as a vertical shift. So I know I have shifted down 3 units. All right, so the next thing I should be reflection about x and y axis. Reflection about x and y axis. That will be reflection about x and y axis. X axis or y axis is about the signs. Okay, it's reflection about x axis if there's a negative sign in front of the function. Right now, there is no sign in front of my absolute value, so I don't have a reflection about x axis. Reflection about y axis, that means there's a negative sign in front of the x that's within the function. Okay, so within the function, look at your x. Within the function, what the x is, that's not negative, it's just a positive half. So there's no reflection about y-axis either. So that would be none. All right. Vertical stretch or vertical compress is the number that's in front of the entire function. There's not a number in front of the entire absolute value. So there's no vertical stretching or compress. Horizontal stretch or compress is the number that is actually in front. Okay, it's a number that is actually in front of the x. So that gets a little bit tricky. The number right now in front of the x within the function is a half, right? So that gets a little bit tricky. Right now it's half x, right? So if this b, okay, the graph compressed horizontally by 1 over b if b is bigger than 1. So this b and that b is the same thing. So right now, the b, okay, compressed horizontally. So if the b is bigger than 1, compressed by 1 over b if b is bigger than 1. So right now the b is a 2, right? Right now b is a 2, which is bigger than 1. So if it's, so you got to think backwards. All right. So right now I'm seeing a half. So basically I'm seeing something like this. So if I'm seeing it like this, like a half x, so that means my b is actually bigger than 1, which is actually a half. It will actually lead back to here. So 1 over 2. All right, this part is always very weird because if I would draw you a regular absolute value, I'm going to draw it real quick. If I draw a regular absolute value of x, it looks something like regular b. Okay. So when we say compress horizontally, that means we are squeezing this left and right. We're squeezing the x-axis. We're squeezing this v from left to right. So if I would draw this as half x, 1 over 2x. Okay. See right here, the v is actually turned out to be wider. So this is where it's tricky. Okay, so does this second v look like horizontally compressed? Think about rubber band or ponytail holder. If this rubber band, if I'm squeezing it this direction, if I'm squeezing it this direction, what will eventually happen with this part and this part vertically? Vertically, it should actually go upward and downward. If I squeeze the rubber band from left and right, then the rubber band, the top and bottom will actually go up and down. So that will actually mean squeezing it from left to right. So earlier I was wrong. This need to be switched. This is why I hate this part. Okay, this is what I hate about this part. This is actually the other way around. Stretch is this way. Compressed. The half tells me it's actually compressed. The numbers are backwards, basically, because it's 1 over b thing. So my b was a half. That's why I highlighted. I hate this part. The b right here, if this is a half, that's a half. So if it's halved, oh, hold on a minute. I'm about to go back to say the wrong thing. If it's a halved, then it's actually, if it's halved, if the b is halved, it's actually stretched out. Yep. If it's half, it's stretched out. Okay. If that b, if that number in front of x is anything between 0 and 1, okay, it's actually stretched. All right. I'm gonna draw you another picture right here. I'm gonna do a 2x. It's almost like it's opposite of the vertical. It's probably easier to explain from that direction. All right. If A, if this number A is actually bigger than 1, it's stretched. If you stretched vertically, that means you're compressed horizontally. If you're stretched vertically, you're compressed horizontally. If you're compressed vertically, you're actually stretched horizontally. It go hand in hand. It's just the numbers also switch. That's the reason why compressed vertically, that means the A is between 0 and 1. Compressed vertically means stretched. Okay, excuse me. Compressed vertically means stretched. That's right. I got these things. Yeah, the way how I wrote it. So if when I do a 2x, when I do a 2x, see the third line, right? That right there is actually compressed. So if this B is anything is actually bigger than 1, it's actually compressed horizontally. If I'm compressing it, if I'm squeezing it in, the picture will actually show you it's actually what? The picture will actually show you it's more, it's actually going upward a little bit or downward. All right. If this number B is anything between 0 and 1, like a half here, that means I'm actually stretching it out vertically. So imagine if this rubber band is going the other way. Okay, if I'm pulling it, then this up and down will actually shrink, will actually go inward. That's what happened to this my wider V. It actually got horizontally stretched. So sorry about that earlier. Kind of say it the other way around. That's why the highlighting was there. I remember I highlighted for some reason. So our half part, this half part, tell me is actually horizontally stretched. So horizontal and vertical stretch and compress, it just saying, it just reflecting to what the number does, okay, what the y value does. And the reason why this portion is so confusing, because these numbers in front of the x affects what the x value do, okay? These number in front of the a affects the y value of the function. That's what they really do to the function. But the tricky part is, and this is what a lot of students don't quite see. If the number in front of x affects x value, and when you actually graphed it, these x value, you don't see any different patterns. Okay, you still don't see any patterns because our x values are already set at integer 0, 1, 2, 3, 0, then going to 2. So that's the reason why when it comes to talking about horizontal stretch and compress, we are trying to look at these look at the x values, but x value from the calculator is already set. So that's why you can't really see the difference. All you see all you see in the difference in picture is what happened to them vertically. When you stretch it out, when you actually stretch your V, your original V left and right, when you stretch it out, okay, that means what? That means up and down wise, it gets flatter. Then that's a horizontal stretch. All right, let's find the x-intercept. This is where it gets iffy. Plus 3 minus 2. Solving absolute value equation. You might have seen this before, you may not. Okay, so again, finding x-intercept means find x when y is equal to 0. So I'm going to start you off with 0 equal to absolute value of half x plus 3 minus 2. All right, so we got two terms. In order to solve absolute value equation, we need to first isolate the absolute value term and make sure it's positive. So I'm going to move my -2 over first. So this is absolute value of a half x plus 3 equal to positive 2. So it turns out absolute value equation will always produce two equations when we take off the absolute value. Why? Because technically this x can either be positive or negative. Just think of this. Absolute value of -4, we know it's going to be positive 4. As a matter of fact, absolute value of any number is always positive. So if absolute value of -4 is equal to positive 4, oops, and absolute value of positive 4 is equal to positive 4, that means absolute value of x that's equal to 4. That means this x technically can be positive or negative. So when we take off the absolute value, we actually need to set my equation equal to a positive 2, and we gotta set up the equation as -2.
It's supposed to be +2 minus 3.
Oh Lord, +2 minus 3. I knew I was messing up. +2 minus 3, okay. Then I would just have to move it around real quick. Yeah, so that would be -2 on this side, right? Awesome. Thank you, thank you, thank you. So normally we will actually, once I take off the absolute value, normally we'll have to set my
No,
equation.
the whole thing's wrong. It's 1/2 x plus 2 minus.
Oh, +2 minus 3.
Sorry.
+2 minus 3. I got you. I looked at it, but I didn't quite remember it. Well, it will still work out for us. All right, move the -3 over, right? So the other side is a 3. All right, so we set what's inside the absolute value equal to a positive 3, and we set it into a negative. Okay, it has to be two equations. So because technically the x inside the absolute value can be a positive or negative. All right, so now we're just solving both equations accordingly. I'm gonna move my positive 2 to the other side. So one of them should be half x equal to positive 1. The other one should be half x equal to a -5. So from here, I can divide both sides by half, okay, or I can time both sides by 2. Either way, x is equal to 2, the other x is equal to -10. So two x-intercepts. So technically this v is gonna cross over the x-axis twice. So my x-intercept, I got to make sure I write them as a order pair, 2, 0, and -10, 0. 2, 0, -10, 0. Okay, it's a very wide end of V. All right, I'm gonna find the y-intercept real quick. Let me change it right here. +2 minus 3. Yep, shift left down. Yep. All right, y-intercept, find the y value when x equal to 0. So I'm gonna substitute. I'm gonna say f of 0 equal to absolute value of a half times 0 +2 minus 3. Half times 0 is 0. So absolute value of 2 is simply just 2. And 2 minus 3 will be -1. So my y-intercept, all right, 0, comma, -1. So if you think back, a regular V, right? The very bottom is also at 0, 0. All right, I just found my y-intercept. We already said we're gonna go to the left 2 and down 3. Left 2, down 3. That should be the very bottom of the V. 0 comma -1 is just the y-intercept. But the shift tells me that the very bottom of the V has went to, well, the easiest point to identify is the very bottom of the V. Okay, that bottom V has shifted to the left 2, down 3. Every single point has shifted the same way. It's easier to use the bottom of the V to identify. So we know it's going to be a V. So I just connect all my points that way, something like that. Not quite accurate because I don't have enough points. So I'm going to delete the first one. I'm going to continue the second one. So absolute value of half X. Hey, sorry about that. Hey, sorry about the interruption. My Wi-Fi just went out, so I'm back. So can everybody see my screen? Okay. So my calculator froze too, so I can't really graph it. But make sure if you want to give a try, find that ABS, okay, and do an extra parenthesis for the half x, then plus 2. Close the parenthesis, minus 3. That's your graph this V. All right. I mentioned before the domain for the absolute value function is always from negative infinity to positive infinity. The range varies, right? The range varies. So remember, what did I shift it to? I shift left 2, down 3. So technically, this point is -2 comma -3. So when it comes to the range of the function, down and up, the very bottom is at -3. Keep on going up to infinity. Okay. All right. So let's take a look at absolute value function. Okay. This one, I didn't dress it up as good. Okay. So I remember mentioning about makeup before. We are basically putting a lot of different things on our function. So this negative x earlier, before the interruption, we saw this negative sign in front of the x will make my graph go this direction. All right. So, this one is a little bit tricky. because that negative sign right there. So let's take a look at your shift. Horizontal and vertical shift is no problem. Is the number plus or minus outside of the function. Wherever your function is, if it's plus or minus, that will be your vertical shift. All right, shift to the right and left. You gotta be very careful. This X I wrote are positive X. Okay, if these X's are positive X, then the sign here should always be minus H for shifting to the right. If it's a plus H, we shift to the left. But right now I have a negative sign. Right now I have a negative in front of that X within the function. Okay, the entire function is positive, so no problem. If it's positive, then when it comes to, let me go back up. If it's positive, okay, then we don't have any reflection about x-axis. Right now, in front within the function, in front of the x is negative, so I know I have a reflection about y-axis. So number 4, I know it's going to be reflection about y-axis. Okay. So number 1 is a radical function. All right, the shift normally is x minus h or x plus h. Right now, my x is not positive, so it's negative x plus 4. So in order for this x to be positive, I have to factor out a negative between these two terms. If I factor out negative between these two terms, my x will go back to be positive. Remember, it's either x minus h or x plus h. So this is actually x minus 4 now. So technically, if we match this up, x with x, minus sign with minus sign, 4 is your h. So that tells you this is actually shifting to the right 4 places from the origin. Remember, this very bottom starting point normally supposed to go this way, right? But that negative sign also tell me it's refreshing about the y-axis. But the bottom part will actually move to the right 4 places from the origin. If you don't believe me, you can just simply just kind of graph it right now by simply typing negative x plus 4. If you're typing negative x plus 4, just without the 2 and the negative 1, you will see this very bottom is going to go into the right 4 places. All right, vertical shift, that would be this part. So that tells me I'm going down 1 place. Shift it down 1 place. All right. This number in front of the function tell me it's vertical stretch or compress. Since that number is bigger than 2, it will be vertical stretch. All right, stretch horizontal or compress horizontal or none. So there is not a number with in front of the x that is within my function. Okay, so this is not a negative 2x or negative 4x, right? This is just 1. So that means I don't have any horizontal stretch or compress. All right, let's see if I can copy this down without getting it wrong. 2 times square root. 2 times square root of negative x plus 4 minus 1, right? No, I'm doubting myself. Yeah, negative x plus 4 minus 1. All right, I want to find x-intercept. So let's take a look. X-intercept means find x when y is equal to 0. So I'm going to substitute 0 right there. Is it 2x? Okay. So 0 equals 2 times square root of negative x plus 4 minus 1. All right, so solving for square root, I got to isolate my square root term, just like the absolute value. Move the -1 over. So that's 1 equals 2 times square root of -x plus 4. All right. So to get rid of the square roots, I need to 2 cannot be here. So let's divide both sides by 2. So that gives me half equals square root of -x plus 4. So now to get rid of the square root, I'll simply square both sides. Why? Because square and square root cancels out. So that gives me -x plus 4 equal to 1/4. All right, move my -x over, become positive. Move the 1/4 over. So 4 minus 1/4 in your calculator. You should probably get 15 over 4. So 15 over 4, if I need to know what that is, that's about a little bit over, almost 4, about 3.75. But for my x-intercept, I'm still gonna write 15 over 4, comma 0. 3.75, so it's a little bit over. One, two, three, a little bit over there. Okay. Now, y-intercept, find the y value when x equal to 0. So I'm gonna do that real quick. So f of 0, 2 times square root of -0 plus 4 minus 1. So that will simply be just square root of 4 minus 1. So square root of 4 is 2. 2 times 2 minus 1, that will just be 3. So my y-intercept, 0, comma 3. 0, 3, that'll be right here. All right, remember the very bottom, I call it the very bottom of my radical. I know it's going this direction because we're flashing about the y-axis. Remember, I have to move to the right 4 and down 1. So this very bottom must be located at 4, 1. So to the right 4, down 4, -1, excuse me. So my picture, you can graph it too. It should look something like this. Okay, that's a decent sketch. All right, that will allow me to find the domain. So remember now, this point now, since it's going the other way, this point must be where the entire function ends at. So the entire function ends at -4, -1. Go to the right is where the function begins. So since I'm going that way, from left to the right for the domain, that means the function ends right here. So the domain got to be from -infinity, using parentheses, all the way to -4, using a bracket. Gotta use a bracket on the -4. All right, the range, the very bottom points must be the -1. So the range is tricky because the range is looking at this from down and up. So the very bottom is -1. So it's actually from -1, keep on going up. So the range got to be from -1 to infinity. All right. So what means the graph of a function will shift, reflect, and stretch? Transformation of the function. All right, number two. Number 2 is very much just like the one I just did with the square root function, okay? Except this time I kind of put a -2x, okay? Put a 2x right here. So determine the type of the basic function. So circle, you can just type it out, which one is it? And then go through these steps. All right, tell me the shift, horizontal, vertical shift, reflection, and whether the function stretch or compress vertically, horizontally. Find any x-intercept on the side, find any y-intercept on the side. The only part you have to do it on the handwritten portion is number 9, step 9. Step 9, I actually need to draw the picture, okay? So remember, Wherever the function is shifted to, that's actually technically is 1 point other, besides your x-intercept, y-intercept. So make sure you use that point to help you to actually draw your picture and answer your domain in the range questions. Okay. So remember that this one, all these parts is actually on the computer portion except number 9. Number 9 is the only part you have to draw on the homework portion. All right, that will conclude this video. Sorry for the interruption earlier.